So in this video, we'll quickly go over the big ideas of chapter 3, which is focusing on rational functions. So the very first lesson, we start off with reciprocal linear functions, and that's a really good idea for a multitude of reasons. Reciprocal linear functions is perhaps the simplest rational function to study, and reciprocal linear functions is something you've done last year, in fact. Based on the transformations of 1 over x, you can basically graph reciprocal linear functions without any grade 12 knowledge. But what we wanted to do was approach it differently. We want to talk about properties of rational functions as opposed to using transformations. But like I said, it's a really good starting point. So after you became familiar with reciprocal of linear functions, we moved on to reciprocal of quadratic functions. And then we moved to a third category or third group of rational functions, which is linear over linear. And then I talked about holes that can exist in a rational function, and they occur when you simplify, when there's a common factor between the numerator and denominator of the rational function. So after that, I gave you a mini workout on graphing rational functions. You really don't want to stop the conversation after studying these three functions. It would be irrational. So yeah, you really don't want to stop the conversation right here. You want to just keep going. Like, why stop right here? So I can do cubic over quartic, degree 4 over degree 10, so forth and so on, right? So once you are able to work, unfortunately, there is some limitation of what you can do. Okay, so if you've done 1, 2, 3, 4, the only rational functions you can work with are the ones where the degree of the numerator is less than or equal to the degree of the denominator. But what if the degree of the numerator is greater than that of the denominator? Then we have this oblique asymptote situation, or in fact, it might be a parabolic asymptote or a cubic asymptote, but we mainly focus on oblique asymptotes. Okay, so after you finish this idea, then you're a rational function graphing beast. Okay, you can do it all. So yeah, it really opens the door, and you can study any rational function you want. So that's what makes it exciting. I really didn't want to limit the discussion right here, or even right after holes, because you can explore anything you want at this point. Okay, so after you mastered graphing rational functions, we can talk about rational equations. So rational equations, you really want to convert them to polynomial equations by multiplying both sides by lowest common denominator. And don't forget to state restrictions, because your roots may be extraneous roots and you might have to reject them. So just be careful. Rational inequalities, really relate the rational inequalities to polynomial inequalities. I know they're different, but there's a lot of similarities in the sense how you filled the interval table or how you filled in the number line. There's a lot of similarities between the order of the zeros when you did polynomial inequalities with the rational inequalities. And in fact, I even showed you that you can convert every single rational inequality into a polynomial inequality. Okay, so you can go back to the lesson and check it out if you want. And lastly, we did some word problems involving rational functions and rational equations. So the hardest part for those rational equations is developing the model. So you had those work rate problems, you had those speed rate problems, the couch problem that we did. But yeah, the hardest part really is generating the model, and then solving the equation should be easy peasy. Okay, so I would say these last three things we did is the algebraic component of the unit. So combine them together, and that's the whole unit. So hopefully you had fun learning about rational functions.